Okay, so step one in successfully completing this warm-up was to just take a moment and fill in what we know about all of the angles in both our degree and radian measure. So our 45, 45, 90, our 30, 60, 90, and then those then turned into like pi over 6, pi over 3, pi over 4, you know, pi over 4, pi over 2, all that good stuff. All right, then it looks like most of you dove into the 45, 45, 90 first. So we're going to talk about that. What I saw that I really liked, I'm having a bad tech day. Okay, what I saw that I really, really liked is that you labeled it first. So I did. Thanks. So I got x, x, and x root 2. So what we're seeing here is that the 1 is equal to x root 2. That's the little equation that we can then solve. So I'm just going to divide both sides by the square root of 2. So I get an x value of 1 divided by the square root of 2. But the problem is we can't have a square root on the bottom. And I heard the discussion over here. Roman and I were just chatting it out. You got to multiply the top and bottom by the square root of 2 in order to get a nice form, right? So x ends up being the square root of 2 over 2. We solved for x. Which means that, yeah, sure, this side is 1. That is the length of the hypotenuse. But now this side and this side, we know a little bit more about them. If those sides are just x, well then we can replace them with what we just learned about x. So the length of that side is just the square root of 2 over 2 and the square root of 2 over 2. So what we're getting into is, I affectionately call these triangles the super special right triangles because it's only 2 of our special right triangles that we actually end up shoving inside the unit circle here in a second. So out of all of the triangles we talked about over the last week, these 2 are the super special right triangles. So your 45, 45, 90 that has a hypotenuse of 1 and your 30, 60, 90 that has a hypotenuse of 1. I guess I'm thinking as I walked around, most of you, and sometimes good mathematicians are just a little, quick and easy. Bless you. I would have just transferred what I learned from the 45, 45, 90 down onto my pi over 4, pi over 4, and pi over 2. So those sides are the same. So hopefully 1 and 3 are good and done. Does anybody have any questions about that part of our warm-up? Awesome. Okay, so we just have basically 2 more to do. One is basically exactly the same as the other. What I did like as I walked around and helped out with this a little bit is that people jumped right into labeling this guy. So this 1 right here was 2x. The short side is x, and the long side is x square roots of 3. So this one's actually easier because you just have to divide both sides by 2 to figure out what x is. So when I solved for x, I learned that x is a half, which then replaces that short side. So I now know what this is. If that short side is x, we now know that that short side is a half. Okay, then we have to take what we know about x and fill it in. So this is like 1/2 times the square root of 3. And when we multiply fractions, you just multiply straight across the top, straight across the bottom. So 1 times the square root of 3, that's the square root of 3. 2 times 1, that's 2. So this side right here is square root of 3 over 2. So if I go ahead and transfer that gem of information down into the next part of our warm-up, what we get there is the square root of 3 over 2 for the long side and 1/2 for the short side. And these are our super special right triangles that we're then now going to go ahead and plug into the unit circle.